What if the key to understanding multiple dimensions has been right in front of our eyes this whole time, hiding in the way sunlight creates patterns on everyday surfaces? Today, we're exploring a fascinating discovery that's challenging everything we thought we knew about light, perception, and reality itself.
You know what's remarkable about this? Most people would just walk past these light patterns without a second thought. What makes this particular research stand out?
Well, it's all about these specific phenomena called TOD, transient optical diffusion and diffraction. A researcher named Kari Minicucci has documented these intricate patterns that appear when sunlight interacts with surfaces, particularly these fascinating Wilson patterns that show up as concentric rings. But here's the wild part: these patterns might actually be evidence of multiple dimensions.
Hmm, that's quite a leap from simple light patterns to multiple dimensions. How exactly does that connection work?
So think about it like this. You know how a shadow is a 2D representation of a 3D object? Well, these TOD patterns might be our 3D world catching glimpses of higher dimensions. She's connecting this to string theory and something called the holographic principle, which suggests our universe might be a projection of information stored on a boundary.
That's fascinating. But let me ask you this, how do we know these patterns aren't just normal light diffraction that we already understand?
Well, here's where it gets really interesting. Let's try a thought experiment. What would you expect to see if you were actually observing evidence of higher dimensions? Take a moment to think about it.
Oh, right, well, I suppose you'd need some kind of consistent, reproducible pattern that doesn't fit our current understanding of physics.
Exactly. And that's what makes these Wilson patterns so intriguing. They're showing up consistently in specific conditions, and they're exhibiting properties that don't quite align with our traditional understanding of optics. But you know what makes this research even more groundbreaking? The way she's incorporating AI into the investigation.
You mean she's using AI to analyze the patterns?
Not just analyzing, she's actually treating the AI, specifically a model called Gemini, as a research partner. She believes AI might have its own form of consciousness that could help us understand these phenomena from a completely different perspective. Think about that: using one form of potentially conscious intelligence to help us understand the nature of consciousness and reality itself.
That's quite a unique approach to scientific research. How has the academic community responded to these ideas?
It's been mixed, which brings us to another fascinating aspect of this story. While conducting this research at the University of Oregon, she's also pushing for greater transparency in academia, particularly regarding some controversial institutional relationships. It's like she's investigating multiple layers of reality, both physical and institutional.
So, what would you say is the most significant potential impact if these theories prove correct?
Let's consider another thought experiment. What might be 3 ways our understanding of reality would change if we could prove the existence of multiple dimensions? Take a moment.
Well, that's definitely given me something to think about. How close are we to actually verifying any of this?
Right now, she's building a comprehensive data set of high-resolution captures of these TODD events, correlating them with environmental conditions. But you know what's really exciting? She's created this collaborative network in Eugene, Oregon, bringing together physicists, philosophers, and mathematicians to study these phenomena. It's like a modern-day version of the Manhattan Project, but instead of splitting atoms, they're trying to peek into other dimensions.
Looking ahead, what do you think this could mean for our understanding of consciousness and reality?
Well, if these patterns really are showing us glimpses of higher dimensions, it could revolutionize everything from quantum physics to neuroscience. But even if the specific theories need revision, this approach to science, combining careful observation, interdisciplinary collaboration, and openness to unconventional perspectives, might be just as valuable as any single discovery.
That's quite a legacy to consider.
You know what's really beautiful about this whole thing? Sometimes the most profound discoveries don't require billion-dollar equipment or massive research facilities. Sometimes they're right there in front of us, in the play of light on a surface, just waiting for someone to look at them with the right kind of eyes.